Good morning, judges. Today, our group will be presenting our project, which is the removal of heavy metal ions from water using marine algae. Heavy metal wastewaters are discharged by many industries. They are known to be non-biodegradable, toxic, and carcinogenic, making them a major environmental problem, especially in developing countries. However, current treatment methods do not work. Therefore, we propose marine algae as a suitable absorbent for these various reasons. Thus, our objectives were to 1. Investigate the absorption ability of marine algae compared to other commercial methods. 2. To find out the type of marine algae with the highest absorption. 3. To determine metal ion absorption at various pH. 4. To find out the effect of absorbent particle size on absorption. The following marine algae species, alva, sargassum, and gracilaria, were collected from East Coast Park. They were then washed, blended, dried, and crushed to obtain a powder form. Now moving on to our methodology, which is summarized below. For batch absorption experiments, 100 mg of the following absorbents were added with 45 ml of 100 ppm metal ion solution into the respective centrifuge tubes. The tubes were then placed on a seesaw rocker for 1 hour, after which they were filtered and diluted appropriately before being analyzed by colorimeter or atomic absorption spectrophotometer depending on the metal ion present. For pH studies, sargassum algae was used to absorb copper 2+ and iron 3+ ions in solutions from pH 1 to 5. pH above 5 was not tested due to metal precipitation. For particle size studies, sargassum algae at the various particle sizes were used to absorb copper 2+ ions. Sargassum algae were separated into the various particle sizes using the standard test sieves.
Now we shall move on to our results. For the batch absorption of CO2+, sargassum algae displayed the most effective absorption of 78.6%. It was much better than activated carbon and ion exchange resins and the other two species of marine algae. For the batch absorption of Fe3+, gracilaria algae showed the greatest absorption of 97.8%, followed by sargassum, which absorbed 87.6% of Fe3+ ions. Both algae outperform activated carbon and ion exchange. For the batch absorption of Pb2+, sargassum absorbed 93.7%, which was higher than activated carbon, ion exchange resins, and two species of algae. From our batch absorption experiment of the various metal ions, we found out that marine algae generally outperform activated carbon. This is probably due to the fact that the pores in activated carbon were too large to effectively absorb the metal ions. Marine algae were found to be comparable to ion exchange resins. This could be because marine algae contain a variety of functional sites compared to ion exchange resins. Sargassum algae were also found to be generally better than alva and gracilaria algae. This could be because sargassum algae cell wall are rich in various polysaccharides compared to the other marine algae. For the absorption of Fe3+ ions, gracilaria was better than sargassum, probably because its functional sites showed a stronger affinity to Fe3+ ions.
For the pH studies on copper 2+ ions, sargassum algae showed the highest absorption of 89.4% at pH 4. Absorption increased as pH increased. However, after pH 4, the differences are negligible. For the pH studies on iron 3+ ions, sargassum algae showed the highest absorption of 81.0% at pH 3. Absorption also increased as pH increased, but only until pH 3, after which it dropped to almost 0%. At pH 4 and 5, iron 3 hydroxide precipitation occurred and almost all of the iron 3+ ions were removed even before contact with sargassum algae. At pH 5, sargassum algae might have leached out its own iron. In general, as pH increases, so does absorption of metal ions. This is because there will be less H+ ions to compete with the metal ions for binding to the functional sites on sargassum algae. For particle size studies, it was found out that the particle size of sargassum algae had no effect on the absorption of copper 2+ ions. As we decrease the diameter of the sargassum particles, the total surface area increases much more. However, we observed no significant difference in the absorption of copper 2+ ions. This would mean that absorption not only happens on the surface of the particles, but also beneath the surface. Hence, during absorption, the metal ions will diffuse past the surface into the inside of the absorbed absorbent before budding occurs.
Therefore, for our project, we can conclude the following. Marine algae biomass is effective in the removal of copper 2+, iron 3+, and lead 2+ ions from water. Brown algae is generally the best adsorbent, followed by Gracilaria, then alga. Absorption of metal ions increases as pH increases, and absorption is not affected by particle size or exposed surface area, as metal ions can diffuse past the surface of the marine algae. The prospect of using marine algae as an adsorbent for metal ions is great. Marine algae has a relatively low cost, making it very suitable for poorer but industrializing countries. Apart from heavy metal wastewater, marine algae can also be used for re-extraction of precious material from mining sludge and for cleanup of radionuclides. Finally, these are our references. These are our acknowledgements, and thank you for your attention.